Algebra 1, Lesson 93. Greetings, students. Today we're just going to do some nice, meaty algebra problems. They look like a lot, but when I teach you the secret, you'll be happy, and you'll go, okay, that's not so bad. Rational expressions, okay. What that tells us is essentially they're going to be fractions, and we're not solving, we're simplifying. They're expressions, not equations. Hi, Gracie. Gracie's pumped. She's come in to see what we're talking about. The problems are big. I'm going to copy, and you can just watch the beast unfold on my page. And do you have a headache yet? It's so much, right? Look at all of that. We have to multiply those things together. Look at that. We're supposed to multiply that together. We're supposed to multiply that together? Well, we don't want to. Oh, excuse me, I yawned, but that doesn't mean I'm bored. I don't want to multiply. As I'm looking at it, these things are factorable. We could factor, I mean, this one for sure, right? We could do that with the two binomials. This one is difference of two squares, right? That's a square of x, and that's a square of 5 with a minus sign in between. So I think, well, I know, let's not be coy about it. I know that if we factor each of these four components, something different might happen. So let's try it. Let's start with this one. That is a difference of two squares. It's x minus 5, x plus 5, right? We don't have to do anything to figure that out. We just know we take the square root of this, we take the square root of that, we give one a plus and one a minus, and we've got it. I look at the denominator here. It looks like the start of a trinomial. It's not the difference of two squares. I don't have a lot of ideas what to do with this, but I can at least pull an x out, right? To make it x quantity x minus 7, right? I can test it to make sure I did it right. That would be x squared minus 7x. Okay, that's what that is. So I did it right. We're going to multiply this. Okay, same thing up here. This isn't quite a trinomial. It's not the difference of two squares, but I can at least go x times x plus 3 quantity, right? That would be x squared plus 3x. That's the same as that. And then this one, I can factor in the most familiar way, I guess, that we've been doing it. I need two numbers that multiply to minus 15 and add to minus 2. I think of 5 and 3. Let's see, I need the minus. There. How's that, right? Okay, so what I've done is factored all four components. Now let's look and see what I've got. I've got a bunch of binomials. I've got one plain x, top and bottom, and because I'm multiplying, I can cancel any of this top and bottom as long as I can cancel within the same fraction, or I can go across because we're multiplying, so it's all going to end up one chunk anyway, so it doesn't matter. So just like our regular rules on canceling, as long as it's top to bottom, then what I'm canceling is equal to 1, and that's fine. So let's see what we can do. X minus 5, x minus 5. X plus 5, I don't see. I'm just going across the numerator just to see what I can find. X, oh look, here's a plain x and a plain x, those cancel. And then x plus 3, x plus 3. So what I've done is I've gone all across the numerator and looked to see if there's anything I can cancel. What's left is my answer, x plus 5 over x minus 7. And yes, that's the final answer. That's kind of cool, right? That's kind of fun. Most students, once they get in the groove of these, are kind of like, all right, this isn't horrible. 93.2. Here's another one. This one, oh wait, plus x minus 6. That's an x. I got excited and wrote the answer first. Okay, and again, we're multiplying these two big gnarly fractions. Plus 7. And when you're doing these for your homework, you don't need to copy it out of the book. As is, oh, excuse me, yawning so much. What you can do is look at this problem in the book and then factor it and write the binomials or whatever it is that you get. That can be the first thing you write down, right? These are all traditional, and so we're just going to factor them. So again, this is what's in the book. You could look at the book and go, okay, first one, x squared plus x minus 6. Okay, they have to multiply to minus 6, add to plus 1, right? There's an invisible one there. So I know that's going to be plus 3 minus 2. Right? Our rule is they have to multiply to that term and add to that. So this could be the first thing excuse me, that you wrote down on your page. Second one. And you can do these in any order. I usually go top, bottom, top, bottom. X squared minus 4x minus 7. So the numbers have to multiply to minus 21. I said minus 7. I tried to help you. That's what I did. My brain's trying to help you. And they have to multiply to this, add to this. So it's x minus 7, just like I told you as a secret. X plus 3. I can keep surprise parties. I can keep secrets unless it's a math secret. And then I'm always trying to help you get the right answer. My brain's trying to tell you. Okay. Excuse me. Pollen. Now we go over here. Same thing. I can write the x in, multiply to this, add to that. And then the fourth one right here, multiply to that, add to that, so it's going to be, right? Now, I will tell you, not always, but most of the time John sets these problems up. He calls them contrived problems because they don't necessarily occur in the wild this way, but he sets them up so that they almost always cancel one binomial on top of one binomial. So if you get an answer that has more chunks that don't cancel out, double check your factoring, right? And make sure you didn't make any mistakes in that stage. All right, let's go across and see what we can find. X plus 3, yep, we got one of those. X minus 2, yep, we got one of those. X minus 7, yes. Okay, finally we get one that doesn't. So our final answer is x minus 1 over x plus 1. And that's the right answer. Kind of fun, right? The canceling process is very satisfying. And the factoring is kind of fun. I mean, it doesn't take a lot of work and it uses your imagination a little bit. 93.3. Okay, now we're going to get into the only twist that I have in this lesson. Let me write down the problem so you can see it. X minus 2x over x squared minus 8. Here's the wild card. Look at that. It's a divided by. Okay, what do we know about dividing fractions? Let's see, how does this go? When you multiply fractions, you go straight across the top, straight across the bottom. But when you divide, we have to flip the second fraction, and then that turns it into a multiplication problem. So the same rule is still true for us. Oh, this is a squared, sorry, I forgot that. It's so sad because I have to find all my own mistakes in this format of teaching, and I miss you to keep me on the straight and narrow. Okay, x squared plus 2x minus 8. Okay, that's the same. This fraction is the one we have to flip. So we're going to put this on the top, and the denominator becomes the numerator, and blah, 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 right? X plus 5x. Make sense? Okay, I don't want to flip it now because then we'll lose all our work. So what I'm going to do is I'm going to squeeze our answer into this space. All right? So now we've taken care of the division by changing the division sign to multiplication and flipping the second fraction. Now this problem is exactly like the problems we've done before. There's no difference. So we simply factor top and bottom, top and bottom. Okay, this one is not a trinomial. It's not a difference of two squares, but we can pull out the x, right? Remember this trick, because sometimes when you get into your homework and you're busy doing a bunch of this style, then you'll get one of these and be like, ah, what? Just remember, it's easier than it looks. Down here, they have to multiply and negative 8, add, so that means it's x plus 4, x minus 2, and then over here, they have to add to 7 and multiply to 12, that's 3 plus 4, right? Everything's positive, yes, and then in our new denominator, we have another one of these freak children that don't go very far. But that's okay, they go far enough, they get the job done. Okay, so now we're ready to cancel. I started, and I just work across the numerator. X cancels that x. X minus 2, oh yeah, we got one of those. X plus 3, no we don't. X plus 4, yes we do. So, our final answer, once again, we get it down to a binomial over a binomial. It's x plus 3 over x plus 5. Double checking, yes, that's the right answer. Beautiful. And then for our final problem in 93, we shall do the same thing. 93.4. This time I'm going to show you the shortcut that I'm perfectly fine with you using in the book, or in your homework rather. It's another division problem. So I noticed that ahead of time, and here's the way I handle it. I copy the first fraction, the first rational expression, but instead of copying the division sign and then the fraction as it's originally written, I'm going to flip it. I'm going to change it to multiplication. Then I'm going to take what in the book is the denominator, and I'm going to put that up top. And then I'm going to put what was the numerator, I'm going to move that down because I have flipped these. It's plus 5x plus 4. Okay, I'm going to double check my signs. Yes and yes. Okay, so there's no need for you to write it down as a division problem. You can mentally flip it before you even write it down. These are all just standard trinomials. And now we're ready to break them down. If you were sitting with me in the Ritzman's dining room, I would not be doing all this work by myself. I'd be making you guys do it. Well, you'd be at the board by now. But here I am. She is really weak. Well, she factors trinomials well. She just can't tell us the answers very well. Her vocal cords just won't cooperate. I'm sure she can do it. But since she can't speak, I'm going to have to do it for us. So this first one, let's see, it's going to be a minus 3 and a plus 2. This one is going to be a minus 5 and a plus 2. There's my plus 2's that are going to cancel. I'm tempted to start canceling, but I'm not going to let myself go too crazy. This one's going to be x minus 5, x plus 4. And this is going to be x plus 4, x plus 1. Okay? If I don't cancel down to a pair of binomials, I'm going to worry about whether I made a mistake, but I'm just going to go ahead and kind of a test of our work to see if it cancels. Okay, x minus 3. I don't have one. Okay, that stands. X plus 2, cancel. X minus 5, cancel. x plus 4. Okay, I feel pretty good about this answer because it's one binomial on top, one on the bottom. X minus 3 over x plus 1. I look, yay! We got it right. Okay, that is called, the full name of this is called products of rational expressions and quotients of rational expressions. I call them canceling problems. It's so much more fun to think of them like that. Think of them that way. Okay, we are done with lesson 93. I will meet you later for lesson 94.